We're now going to move on to more targeted syntactic evaluation and be focusing on filler gap dependencies. Now, you've already seen filler gap dependencies. An example of these is the relationship between a relative pronoun like who or what and a relative clause like the woman who was carrying the bag. The woman is the head of the relative clause, who is the relative pronoun, who was carrying the bag is the relative clause, and the woman, of course, plays the role of the subject. That's a subject extracted relative clause. Filler gap dependencies are one of the most theoretically interesting kind of syntactic phenomena in language. They are the subject of a lot of work in syntactic theory, and they're a great example of the kind of long-distance dependency. In fact, they're the sort of paradigm example of long-distance dependency in language. Not only can the relationship between a filler like who and a gap like the missing subject or the missing object span an arbitrarily long distance in terms of number of words in a sentence, but as you saw earlier in the semester, it also can span an arbitrarily large chunk of tree structure. As long as the filler is structurally above the gap, it can be embedded many, many, many levels down. For that reason, and also historically for NLP, filler gap dependencies have been hard things for systems that actually perform well in the real world, that have good application value to succeed on. Part of this was historically because n-gram models, before the advent of deep learning, were really the state of the art in terms of overall broad coverage language modeling, and n-gram models are obviously intrinsically unable to capture filler gap dependencies. So let's look at them in detail and see how we can evaluate the performance of contemporary deep learning models on filler gap dependencies. So we'll start off with the sentence. I know that the lion devoured the gazelle at sunrise. I think all of you will agree that this is hopefully an interesting sentence, but most importantly, it's well-formed. There's nothing structurally wrong with it, so I'm gonna give it a green check. Notice I'm gonna draw your attention to the relationship between two parts of the sentence, the word that and the word gazelle. There's actually no structural intrinsic relationship between these two parts of the sentence in this version of the sentence, but I'm going to change the sentence in ways that induce a potential relationship and in fact a real relationship in some versions, so pay attention to them. Notice in this case that if that is the word that, if this position 1 is the word that, and the position 2 is the word the gazelle, is the phrase the gazelle, then this is a perfectly well-formed sentence. This has a particular tree structure, and you'll notice that there's a kind of embedding. So structurally, I know is the top, and this should be familiar kind of structure to you from earlier in the class. It introduces an entire clause that's introduced by that, so that is what's called a complementizer. And the lion devoured the gazelle at sunrise is the embedded clause, and it's semantically it's the thing that I'm saying I know. Now, here's another version of the sentence. So this relationship that and the gazelle together is fine. And we're going to call that the minus filler minor gap version of the sentence. The reason we're going to call it that way is that I'm going to contrast it with a different version of the sentence. I know what the lion devoured at sunrise, the second version of the sentence. You probably also feel that this is a perfectly reasonable sentence. Okay. In this case, there is a structural relationship between these two positions in the sentence. The word what is now a filler. It has the same kind of behavior as the word what when used as a relative pronoun, although in this case it's not a relative pronoun. And it has a particular relationship with what? With the missing content after the word devoured. Ordinarily, devoured is a transitive verb that obligatorily requires an object, but in this case, devoured seems to be fine without it. The reason for that is that the word what serves the syntactic and semantic function that devoured is looking for its object. Even though what doesn't appear after devoured like an object normally would, it is able to fulfill that function because it is entered into a filler gap dependency. The dependency can be characterized as a dependency between the relationship between the word what and the word devoured, or the word what and the lack of material immediately after the word devoured, which is often called the gap in syntactic theory. For this reason, I'm going to call this sentence the plus filler plus gap version of this sentence, and you'll notice that it's perfectly well formed. Now, we're going to contrast this with another version. Suppose I create the plus filler minus gap version of the sentence. So I'll have change the word that to the word what, but I won't get rid of the word gazelle. You now find that this sentence is odd. I know what the lion devoured the gazelle at sunrise. There's something wrong with this sentence. In particular, it's not clear what role the word what plays. And that's because what is a filler word, and so it needs a gap, but there's no place for the gap to be. There's no object or subject that's missing from that clause, devoured. So this is a bad version of the sentence. This relationship between what and an overt filler an overt manifestation of the object in the gap is not okay. Conversely, if I maintained the gap and I changed what back to that, it would also be bad. I know that the lion devoured at sunrise. If you hear that sentence, you're probably thinking, what did the lion devour? And the reason is that you think that because whatever the object it devoured would be, it's missing from this sentence. So likewise, because that is not a filler, it cannot play the role of the object it devoured. And so this is also a bad version. So now we have what is called, once again, this is a factorial 2x2 setup. And so the presence or absence of the filler and the gap has to be paired. Either the filler and the sentence has to be minus filler minus gap, so there's no filler and no gap, or it has to be plus filler plus gap. There has to be a filler and a gap. Both of those things have to hold, or neither of them has to hold for the sentence to be okay. If only one of the two holds, then the sentence is bad, as you see in the middle cases. So how do we evaluate that? How do we evaluate whether a language model knows that? And I'm going to show you that we're going to separately look at versions with and without the gap and think about the effect of changing the word that to a what. So changing plus versus minus filler. So here's a different version of this pair. I know that my brother said our aunt devoured the cake at the party. Perfectly fine. I know what my brother said our aunt devoured the cake at the party. Something's wrong. So now let's look at the way that a language model puts conditional probabilities, as a left to right language model, puts conditional probabilities on these strings given the context. So this is the Josefovitz et al. Model, but you'll see later on that other contemporary models also do very well on this. So this is the surprisal of the region conditioned on the preceding context for the what versus that versions of this sentence. And I want to draw your attention to a few different things. So first of all, the I know what versus I know that parts of the sentence are a difference in surprisal. This is the summed log, negative log probability of this part of the sentence given the preceding context. This is different simply because the words what and that are different. And in particular, it turns out that what is pretty probable after I know, and that is less probable, and so the I know that version is more surprising. But that's not really of interest. The interest is what happens afterwards. There's no really effect on the my brother said part, but what does change is the following. So first of all, at when you hit the subject of the sentence, you'll see that there's greater surprise in the what version than in the that version. And the reason for that is that what creates an expectation for a gap, and the subject of the sentence is the first place that that expectation could be fulfilled. So that is a highly human-like interpretable pattern of processing that we see in the neural language model. Okay, so there's a surprise effect of having what in at that point in the sentence. There's a second location where it occurs as well. Excuse me. We saw it at the first location. There's a second location where it occurs as well, and that's at this position, the cake. And that the reason for that is that the cake is also a location where we could have a gap effect. So the model is constantly expecting that this filler, which it encountered early in the sentence, will be discharged in the form of a gap at some point in the sentence. And every position that it fails to see that, it's surprised. And so there's a surprise effect both at the word what, both at the subject and at the object of this sentence in the minus gap condition. Now I'll contrast that with the opposite cases where there's a gap. Okay, and now we can still look at the difference in processing of that versus what. And of course, the first part of the sentence is the same, all the way up through devoured, because nothing has changed from the first two sentences to the second two sentences. But in the second two sentences, now we see a different behavior. There's no gap, there's nothing in the gap spot. So the next thing after devoured is at the party. And what you see actually is a reversal of the surprisal effect. So now in the that condition, the model is more surprised than in the what condition. And that's not odd at all either. That's a very human-like pattern, because in the that condition, because devoured is an obligatorily transitive verb, there should be a strong expectation that what will come next is an object. But there's none. And so it's surprising to skip over where the object would be and hit the phrase at the party. In the what condition, on the other hand, because the model expects a gap, there's nothing odd about moving from devoured to at the party. And so that manifests in the surprisal differential, which is the reverse of what we saw in the left panel. Okay, so those are the two different conditions. We can, and these are the locations of that effect. We can actually combine those, and what we're going to do is, just going back here, just to show you this, I want to, in each of the two panels, I'm going to subtract the blue line from the red line. And that will give me what I'll call a WH effect, which is a surprisal difference for the region. And it turns out that that tells us a lot about the behavior of the model. Okay, so this is the what we call the WH effect in each region for the plus gap versus minus gap conditions. So in the minus gap or no gap condition, which is the solid green line, as you saw before, there's a surprise effect at the subject, our ant, because changing that to what should increase your surprise that there's no gap at the subject. And then the second location is here at the filled gap, at the object. Okay, so that's what we saw in the left panel of the graph. And then this effect here after the gap, in the gap condition, is that expectation for the object to be skipped over and to get something immediately afterward. And that is the reduced surprisal by the WH. So in some conceptual level, we can sort of measure the size really between these two locations. And that's sort of the size of the WH effect. And to the extent that that's reliable and big, then the model has done successful learning. So we're going to now use that difference in examining the behavior of the model in a variety of other circumstances. So here are some other features of WH dependencies, filler gap relationships. First of all, they're unbounded. So here's the simplest version of this. I know what our mother gave to Mary last weekend, and we already saw one level embedding where we introduce our mother said that your friend. So we increase a level of clausal embedding. We'll call those the 0 and 1 level clausal embedding versions. But you can actually extend this out to 2, 3, 4, or as many as you want in principle. The sentences can get harder to understand, but they still have a robust relationship between the filler and the gap, and they're still grammatical. I know what our mother said, that her friend remarked that the park attendant wondered whether people stated that your friend gave, skip the object, to Mary last weekend. Should be perfectly fine. So we can ask, as we increase the number of clausal embeddings, is the filler gap relationship still robust? And it turns out that the answer is yes, although the amount of robustness, sort of the constancy of the effect size, is different in different models. So for example, in the Josefovitz et al. Model, which is the giant LSTM that we saw and looked at last time, it really, increasing the embedding length, embedded number of embeddings doesn't change anything. For the Guler-Dauber model, actually increasing the number of embeddings sort of shrinks the WH interaction effect, but there's still an effect even at four levels of causal embedding. So that's very successful. So that's the unboundedness. Now, here's a question that you might ask. As I argued before, the dependency between a filler and a gap is a hierarchical dependency. It is not a linear dependency, just something like if something comes earlier in the string, then something has to come later. That dependency should be describable in terms of syntactic structure, which is hierarchical. And the model's actually learning that. And we can actually do a test of this, which is as follows. One crucial fact about the syntax of filler-gap relationships is that the filler has to be appropriately, quote unquote, above the gap. Okay, so if gamma here is the filler, then in a sort of syntactic tree schematic, the gap should appear somewhere inside the sister of the filler, okay? And so we should not be able to put a gap up here. It's something higher than the filler. And we can test this. Here's an example. The fact that the mayor knows who. There are different ways that this sentence could continue. Here's one legitimate way that the sentence could continue. The fact that the mayor knows who the criminal shot shocked the jury. This is fine. The filler is the sister of the phrase in which the gap appears. So this is okay. But what would not be okay is another version. The fact that the mayor knows who the criminal shot the teller shocked. Here, the gap is syntactically above the filler, and that is not okay. There's no gap inside the sister of the filler. So that should not be okay. Correspondingly, you probably find this an odd sentence, the fact that the mayor knows who the criminal shot the teller shocked. First of all, there's nothing that corresponds to who, and shocked is missing an object. So what this should mean is that we should see this sensitivity between filler and gap inside this phrase, but not outside this phrase. And we can test this with looking at the behavior of models in this case. So These are examples like this. The fact that the policeman knows, and then we have a who versus that effect, versus who versus that difference. The criminal shot the old widow with a gun, reassured the mayor last year. So what we're going to do, this is the no gap condition. There's no gaps anywhere, and we can see where the model is surprised. Okay, and this is going to be just the individual sentences, the who versus that conditions. Okay, and so what you see is that there's a surprise effect here. That the model is surprised not to get, the model is surprised, more surprised in when there is a filler to get an object of shot than when there is no filler. So changing that to who makes the model more surprised at the old widow. Where it does not make the model more surprised is the mayor, the object of the main clause. So this is inside the potential zone for a gap. This is outside the potential zone for a gap. And so actually the behavior of the model corresponds to the syntactic generalization, the hierarchical generalization. If this were a linear generalization, there's no reason to expect why you wouldn't see an effect at the mayor. So that's the first result. Now let's look at the behavior when we omit the object of shot inside the zone where we should be able to be sensitive to filler gap effects. And so what you can see here is that when you skip over shot and go immediately to something after shot, you see that reverse effect that you saw in the simplest case. You see that having that makes the model more surprised because it expected an object after shot. We didn't see one, and so that's surprising. Whereas with who, we expected to have a gap, and so skipping over the object is not weird. Finally, we can look at the version where the model is where there's a gap in the wrong position. That is, that there's a gap in the main clause where there should be no sensitivity to the filler gap dependency. And so what we see here is that skipping over the gap, that there's no sensitivity to whether there was who versus that in the context. So there actually seems to be learning of a hierarchical relationship. That is, the filler gap dependency that's been learned by the model is not a simple linear dependency. It is a hierarchical dependency. And that's really a remarkable fact. This is an LSTM model that's just trained on a lot of text. And these subtle implicit syntactic structural sensitivities seem to emerge. We can, of course, do this WH effect view, and this gives us the same view. So there is a surprise at not having a filled gap at the old widow. There is a surprise at skipping over the object in the reverse direction, that is more surprised than who. And then we also see, we do not see any appreciable sensitivity here. So these are exactly, there's sort of, there's almost no effect here. And then finally, there's no skipping over the filled gap effect here in the main clause. So that's actually great. So we've actually ruled this out because we've shown that RNN models that are trained on enough data are sensitive to syntactic hierarchy for WH dependencies. We can also ask, by the way, at this point, what about syntactic supervision with small amounts of data? So we can go back to our recurrent null network grammar that we talked about last time. And what we can do is we can, this is supervised training, so we have syntactic trees. And actually in the Penn tree bank, as you may have seen before in earlier on the class, there are actually annotations of the filler gap relationship. So that's actually marked in the tree bank. So we need to strip those out. So we're going to get rid of those so that the model is trained on syntactic trees that do not themselves have filler gap relationships annotated. And what we see is for that syntactic hierarchy evaluation, for example, that we see that, so this is when you have a filler gap relationship that you're examining inside the subject versus inside the matrix clause, that a sequence-only model really doesn't learn anything about the filler gap relationship reliably that shows up in either of these contexts. But the grammar-based model actually learns that relationship in a syntactically, structurally sensitive way. So it learns that filler gap relationship here, but it does not generalize it to the matrix clause outside of what should be the domain for the filler. So that's actually a real success story of the role of grammatical supervision in the small data regime. But there's a second concern that I think you should have, which is that, actually, sorry, I'm not going to go into that yet. I'm going to talk about islands. We'll actually take a break right now for just a moment or two, and then I'm going to talk about islands because that gets into our third case, which is the third part of what we're going to talk about today, which is learnability.